Okay guys, today we are going to have a look at compound interest. So last lesson we looked at simple interest. Today it's a similar concept, so still the idea of interest or money being paid at a regular rate for either owing money or being given money in terms of interest. It's all the same stuff, guys, but we're going to look at interest that is worked out when it's compounded rather than just a simple interest rate. We're going to have a look at what that means and some examples. So, what is compound interest? So, unlike simple interest, you'll want to write this down, okay? This bit just here. Compound interest is when interest is added onto investment total before the next amount of interest is calculated. We say the interest is compounded. Now, what in the earth does that mean? So, previously, we would have worked out the simple interest. We would have said, okay, $1,000 investment at 8% per annum over 3 years, and you'd work it out at the end, okay? Or I equals PRN. With compounded interest, on the other hand, it is a little bit different, okay? Say, for example, we invested $1,000 at 8% per annum. After the first year, that investment would have occurred in $80 because that's 8% of 1,000. So by the time I come to work out the second year, I'll actually be working with compounded interest of 8% of 1,080, okay? Because it is compounded or it's built on top of. So if that's for 5 years, I'd be getting $80 in the first year and then 8% of 1,080 because it's being compounded. Okay, so it's a little bit different. It's the idea of building on top of, not just one lump sum at the end. So let's have a look at an example. Not simple interest, compounded interest, okay? So I need to find the total value of an investment if $8,000 is invested at 5% compounded. Now, whenever you see the word compounded, I would like you to underline it. The other things I'd like you to underline is the principal, 8,000, the rate, and the time period, okay? Find the total value of an investment if $8,000 is invested at 5% compounded, not simple interest, compounded annually. A reminder, the word annually means per year. If something's annual, it happens per year, annually, okay, for 4 years. So, how do I work this out? Well, I agree by the end of the first year, I'd have all of the 8,000, so 100% of the 8,000, plus I get 5% on top of that. So one way I can write that is 1.05. That represents all of the 8,000, 100% of it, plus 5% more. So if I multiply 8,000 by 1.05, I get what I get by the end of the year. So 8,000 multiplied. But I've got a problem. I'm not just investing it for 1 year, I'm actually investing it for 4 years. So I actually have to multiply 1, 2, 3, 4. Each time I'm multiplying by 1.05, it's taking 100% of the previous value. So 8,000 multiplied by 0.15 will get me 8,400, and then when I move on to the next one over here, I'll be multiplying 8,400 by all of itself, plus another 5%, and then so on and so forth. But to me, that actually looks a little bit dodgy. 8,000 multiplied by 1.05, 1.05, 1.05. There's actually a cleaner way I can write that. I'm happy for you guys to write it this way if that's what you're comfortable with. But also, if you think about it, another way of writing 1.05 is 1.05 to the power of 4, because there's 4 years. Either way I write it, guys, my answer will come out as 9, 7, 2, 4, and 5 cents. That's how much I would earn, how much my total value of my investment if my principal is 8,000 and it's invested at 5% and it's compounded annually for 4 years. So as you can see, compounding interest ends up producing a greater value than simple interest. Okay, let's have a look at another example. After 6 years, a loan grows to $62,150. If the interest was compounded, I'm underlining the word compound, at a rate of 9%, find the initial loan to the nearest dollar. Okay. That's a bit weird. Now I have to go the other way. So I have the initial amount. Now I'm going to call the initial amount IA just for the moment. That's my initial amount. And I know if I followed the same step as I did before, 9%, so 100% of itself plus 9, and it went for 6 years. Okay, because I know my loan went for 6 years. It would have come to 150. So I did it in the previous step. I had my initial amount, I multiplied it by the rate and then per the number of years to find my answer. Now I've got a bit of a problem because I actually have to work the other way back. So initial amount multiplied by the rate per year will give me my final value. Okay, so initial amount, good. Okay, what can I do now? Well, if I'm looking at this is actually just an equation. It's saying initial amount multiplied by all of that equals 62150. I need to find my initial amount. I need to find, as you guys would have learnt last year, my pro numeral. So if I move this over to the other side of my equation, I know I need to do the opposite. So it becomes initial amount equals 62150 divided by 1.09 to the power of 6, because I've moved it from this side to the other side of my equation. And then if I worked that out, I would get an answer of $37,058. That $37,058 represents the initial loan amount. It represents the initial loan amount. And that's it, guys. That's compounding interest. It's pretty much exactly the same as the other one, as simple interest, but it's this idea that the investment is built upon each and every single year, or quarter, or month, depending on the number of time periods that the question is asking you.